Good evening, students. Today I will continue with the next part of SHM, that is simple harmonic motion. In the first video, I have discussed what you mean by simple harmonic motion, what is harmonic motion, what is periodicity, all these things, and also I have discussed the expression for the simple harmonic motion. I have also said you that in the next video I will continue with the Fourier part, right? So, in the previous class I have shown you what is the general equation to represent a SHM, right? So, according to the Fourier, the mathematician, he had said that a simple harmonic motion can be represented by the superposition of sine and cosine function. Okay, so let us start how it can be represented. Okay, so this is the basic equation or general equation for the simple harmonic motion, right? Now, for example, according to the Fourier, he had said that any periodic function, or as simple harmonic motion is a periodic function, so that is for simple harmonic motion this theorem or this statement can be applicable. Okay. So, any periodic function can be expressed as a superposition of sine and cosine functions of different time period, right? So, let us take an example y, which is the displacement of the simple harmonic motion, that is sine omega t plus cos omega t. Okay. So, this part we can write like this: root 2 is being adjusted here, cos pi by 4 plus cos omega t sin pi by 4. Okay, why? Look, sin omega t is here. Here I can, if I write an into 1, if I write here 1 by root 2, so what will be the value of 1 by root 2? That is cos 45 has the value of 1 by root 2, as well as sin 45 also have the same value, that is 1 by root 2, right? Therefore, sin omega t cos pi by 4. If I write this expression and if I write this sin omega t, that is 1 by root 2 is the thing which is extra added here, right? Therefore, we are adjusting root 2 here. Okay, same thing is happening for cos omega t. For cos omega t, I am writing cos omega t into sin pi by 4. So, what is sin pi by 4? Sin pi by 4 is same as 1 by root 2, and here I am adjusting root 2, right? As I have written like this, that is sin omega t cos pi by 4 plus cos omega t sin pi by 4. You may say like this: sin A cos B plus cos A sin B, right? So, what is the formula of this according to the trigonometry? I think all of you know this, that is sin A cos B plus cos A sin B is the formula of sin A plus B, right? So, therefore, this expression can be written as root 2 sin omega t plus pi by 4. Okay, I can write this. Now come to this part. Y is written as root 2 sin omega t plus pi by 4. Okay. Now, instead of this pi by 4, I can write like this: plus 2 pi. Okay. Now from this expression I am writing root 2 sine, taking omega common, so the result will be t plus 2 pi by omega plus pi by 4. Okay, so this is the derivation where what I have said, where the periodic time of this function is what? That is 2 pi by omega. Hopefully it is clear to all. Next thing is that we can take another example. Here we have take that y equal to sine omega t plus cos omega t, right? If we take like y equal to sine omega t plus, let me remove this part, first erase this part. We may write that y equal to sine omega t plus cos 2 omega t plus sine 4 omega t, like this. And again this expression can be written as like the previous one, that is sine omega t plus 2 pi by omega plus pi by 4. In the same way, we can write this. This expression can be written like this as well. Okay. Therefore, it can be noted that each of these terms can be represents a periodic function of different time period. What is the time period of this? That is omega. What is the time period? That is 2 pi. Here is 2 omega and here is 4 omega. Okay. So, since the period is the least interval of time after which a function repeats itself, so sine omega t has the time period of, that is sine omega t has the time period t, that is 2 pi by omega. So, if I write the cos 2 omega t, then what will be the time period? The time period will be 2 pi by 2 omega. Similarly, if I write the time, the expression as sine 4 omega t, so the time period for this will be 2 pi by 4 omega. Okay. So, here the time period will be t by 2. Here it will be t by 4, like this. Okay. So, the least value is this and others are the just multiple of this term. Okay. So, this is the concept of periodic function according to the Fourier. Okay. So, next coming to the oscillatory motion. What do you mean by oscillatory motion? If a body in a periodic motion moves to and fro about a definite point, then the motion of the body is a vibratory motion or oscillatory motion. Okay. What is the to and fro about a definite point? Suppose a pendulum is there. Okay. At a certain interval it comes here, then comes here, again due to the inertia it comes here. So, this is the original position. Due to the application of some force it goes here, comes here, stays. Due to the inertia again it goes here and comes here. So, this is the one complete motion. This is the to and fro motion of a particular body with respect to this mean position or equilibrium position, right? Therefore, this is called the oscillatory motion or vibratory motion. Okay. So as the body goes to one side of its equilibrium position or mean position, comes to back to its equilibrium position and goes to another side and again return to the same position. From this position goes to this side, again come to this side, goes to this side and comes to this side, right? So as this is moving to and fro, motion is there with respect to this initial position or mean position, this is called, that's why it is called the oscillatory motion, and this is one complete oscillation or one complete vibration. Okay. Now, what is this point? These two are called the extreme points, okay, up to which it moves to the side from its initial or mean position. Okay. Similarly, harmonic motion. What do you mean by the harmonic motion or harmonic oscillation? Harmonic oscillation is the oscillation which can be expressed in terms of simple harmonic function, that is the superposition of sine or cosine function. Okay. So, if a harmonic motion or harmonic oscillation of a constant amplitude and of a single frequency, that is called the simple harmonic oscillation. Okay. Now, for the harmonic oscillation, when a body slightly displaced, suppose this is the pendulum, when a body slightly displaced from its mean position and left, it begins to oscillate to and fro about its mean position, that is in the previous case. But then why this motion is happening or why this body starts to move with respect to its mean position? Because they begin to oscillate in such a way that the force or acceleration acting on that body is directly proportional to the displacement of the body. Okay. So, let us explain these with the diagram. Make it a convenient diagram with a better picture. So, this is the mean position of this bob, right? When it starts to move with rest to and fro, or it begins to oscillate to and fro about its mean position, so therefore a force is acting on this bob, right? So, as the force is acting upon this bob, we can say that the acceleration or the amount of force acting on this bob is directly proportional to the displacement occurring or happening to that body. So, from this mean position it is going to this part, though it is not in a straight line, but we are, as this theta is much less, so therefore we are considering it is as a straight line. So, if amount of force or acceleration is F, so F will be directly proportional to X and there will be a negative sign. So, why this negative sign? As the force is acting in this side, when the body starts to move in this side, again at this point or at that extreme point, what is happening at the extreme point? Basically, the potential energy becomes maximum and the kinetic energy becomes 0. So, it rests here or it stops here. Therefore, though the force is acting here, but it returns to its original position. Okay. Therefore, this negative sign is introduced here. Okay. So, what is this? When this format or this formula is applicable, this is applicable only when there is the absence of the frictional force. Okay. Hopefully, it is clear to all. Okay. So, next thing is that what is the mathematical expression of this simple harmonic motion? Okay. So, the expression for the simple harmonic motion can be written as y equal to a sine omega t, right? So, instead of omega, we can replace it by 2 pi by capital T. So, a sine 2 pi by capital T into T. This is one expression. And in the previous part, I have just said that according to the Fourier, an harmonic and oscillatory motion, not harmonic, and oscillatory motion can be represented as the superposition of sine and cosine, right? So, therefore, as simple harmonic motion is one kind of oscillatory motion, we can represent this simple harmonic motion with respect to the as the superposition of sine and cosine simultaneously, right? So, here I have written that y equal to a sine omega t, where omega is replaced by this. Same thing I can write y equal to a cos omega t. Same thing will be happen. Omega will be replaced by 2 pi by capital T, right? Now, what is this y? Y is basically the displacement of the body from its mean position at time instant t. A is basically the amplitude of the harmonic motion. Omega is the angular frequency and capital T is the time period. Okay. So, for sine and cos, what will be the graphical representation of this harmonic oscillation? Let us write, or let us just see this. If this is y and this is t, so this is the sine omega t representation, where this is basically t by 2 and this is basically capital T. One complete representation or one complete oscillation, right? So, this is the sine. If I want to express the same harmonic motion using the cos, then what will be the wavelength, or what will be the graphical representation? The graphical representation will be like this. Will be like this. This is one complete oscillation. This will be the t by 2 and this half will be t. So, this is the representation of cos omega t, right? And what is A? A is basically this amplitude is called the A. Here this is A, this is A. Okay. So, hopefully it is clear to all. So, in the next video, I will continue with the simple harmonic motion as the representation of the uniform circular motion. Okay. Thank you.